All right, so when we left, when last we met, we were doing things like this. I might give you a right triangle. And I might tell you that this side over here has length 12 and the hypotenuse has length 16. And I might say solve that triangle. How would you do it? Well, what does it mean to solve the triangle?
Find the sides of the angles.
Find all the sides and all the angles. So I got to find this side, and I have to find these two angles. Well, I think this side is easy. How would you find this side to start with? Pythagorean theorem. I'm going to call this b. So I would have 12 squared plus b squared is 16 squared. So b squared is, I grab my calculator here, 16 squared minus 12 squared. Calculator says that's 112. So b is the square root of 112. All right. This angle right here, I'm going to call this angle B. And this angle up here, I'm going to call this angle A.
And isn't it always the sides are lowercase and the angles are...
Correct. The sides are usually given as lowercase, and the angles are given as uppercase. And if this is side B, then this is typically angle B. Angle B is always opposite of side B, which means this one has to be side A down here. So that one has to be angle A. All right, how would you find angle B? I would say cosine of B is 12 over 16, adjacent over hypotenuse. And you're absolutely right, to get the B all by itself, I would do inverse cosine. So B is inverse cosine of 12 over 16. Calculator says, I'll call it 41.4 degrees, rounding to one decimal place. Okay. And then finally, how would I find angle A? I could say A plus B plus C all have to add up to 180 degrees. So A plus 41.4 degrees plus 90 degrees has to equal 180 degrees. So A is 180 minus 90 minus 41.4. Calculator says 48.6 degrees. All right, so that's kind of where we left off. It's kind of the last stuff we were working on. What we're going to do in section 6.5 and section 6.6 is talk about how do you solve a triangle if the triangle is not a right triangle. What's the first problem if the triangle is not a right triangle? Well, I can't do things like cosine is opposite over hypotenuse. That only works if I have a right triangle, so I can't do that kind of stuff. If I don't have a right triangle, can I use the Pythagorean theorem? No, the Pythagorean theorem only works when you have a right triangle, so we can't use those things.
Are there different theorems?
There are. There's one rule called the law of sines, and then on Wednesday we'll cover section 6.6, which is called the law of cosines. So there's two different rules we'll have to use depending on the problem. And we'll talk about when do you use sines, when do you use cosines. Okay, so we already kind of said this. We're going to draw triangles this way. So this is any old triangle. It doesn't look like a right triangle. I don't mean it to be a right triangle. I'm going to call this angle A, which means side A is over there. And I'll call this one angle B, which means side B is over there. And this one will be angle C, side C will be over there. So again, angles are usually given capital letters, sides are given little letters. And we have the rules of opposites. If A is here, then little a is there. If B is there, then little b is there. All right, do you remember back a couple sections ago when we had a triangle that was not a right triangle, we had a formula for finding the area. Anybody remember how that worked? What was our formula for area? It's 1/2 base times height. Okay, but the problem we have is the height for this triangle is this much. I have to make it a right triangle to know the height. So there's the height. So area is 1/2 times base times height. But what's the height? Well, would you agree that sine of angle A is h over b? Because now I do have a right triangle. Which means the height is b sine A. So for this triangle, I shouldn't have used b because b is not that b. I'm going to actually write the word base in there. What's the base? The base is C. The height is b sine A. So area turns out to be 1/2 times C, the base, times the height is b sine A. Again, I should write the word area because A is not that A. Now, I could do the same thing. I could rotate this triangle to make it so that A is the base and do the exact same thing. And I would get, if I did that, I would get area is 1/2 A times B times sine C. So that means that 1/2 times C times B times sine A has to be 1/2 times A times B times sine C. Because the area is the area. They have to be equal to each other. What can I do with this equation? Any good ideas? Well, how about if I were to multiply both sides by 2? Is that a good idea? Yeah, why? Get rid of the fractions? Alright, so I'm going to write this as BC sine A equals AB sine C. What else can I do to that equation to make things a little bit easier? How about if I divide both sides by B? Is that a good thing? Yeah. So C sine A equals A sine C. All right, the last thing I'm going to do is I'm going to take this equation and I'm going to divide both sides by A times C. I get sine A over A equals sine C over C. And that's known as one of the law of sines. There's actually more than one law. That's one of them. I could do the exact same rigmarole over here with my area and get a 1/2 AC sine B. And if I did that and solved everything, I could also show that that's true. So this whole thing is usually known as the law of sines. So there's a proportionality. I can take sine of big A divided by little a, I'll get the same as sine of big B divided by little b, I'll get the same as sine of big C over little c. Alright, so I'm going to make up a triangle here. Here's a triangle. Looks like a right triangle, but it's not, because this angle right here is actually 88 degrees. Looked like a right triangle, but it wasn't. And this angle over here, how much is this angle? This is 43 degrees. Is this angle A, B, or C? This is C. Okay, so C is 43 degrees. 88, which one is that? It's A. Does it really matter which one I call A, which one I call B, which one I call C? No, it doesn't matter at all. All right, so angle B is up here. And then this side over here, this would be little c. Little c is going to have a length of 12. All right, so I want you to solve that triangle. What's the easy thing to find?
B.
Big B is easy to find. Why is big B easy to find? They all have to add up to 180, right? So big B is 180 minus 88 minus 43, and I grab my calculator. 180 minus 88 minus 43. That has to be 49 degrees. All right. Now, the thing to notice is that I have a pair. What I mean by that is I have a big C and a little c. In order to use the law of sines, you always have to have a pair like that. You've got to have a big C and a little c, or a big A and a little a, or a big B and a little b. Always have to have a pair. How does that help? It allows me to plug it in. For example, I can use sine of big C over little c is sine of big A over little a. Do I know big C? Do I know little c? Do I know big A? Yeah, so I can plug everything in. The only thing I don't know is little a, and then I can solve that equation. So I'm going to have sine of 43 degrees over 12 equals sine 88 degrees over A. So this will be A over here. How do I solve that equation? Yeah, you cross multiply. That's exactly right. So I'm going to have 12 sine 88 degrees equals A sine 43 degrees. So A is 12 sine 88 degrees divided by sine 43 degrees. And you got what? 17.6. Okay, very good. Rounding to one decimal place. A is 17.6. All right, so I'm almost done. The things I had to find big B. I found big B. I had to find little a. I got little a. What's left? Little b. How do I find little b? Exact same process. I don't use the Pythagorean theorem?
No.
How come I don't use the Pythagorean theorem? So it's not a right triangle. And that's a mistake people will make at this point. They'll use the Pythagorean theorem. You can't. You don't have a right triangle. I have to do exactly the same thing. So I'm going to do...
Will there be triangles drawn like a right triangle, but not the same? Because yours is sort of drawn like a right triangle.
Right, mine looks like a right triangle. Usually they won't even draw the picture for you. So I'll do one in a minute. Show you what I mean. So I'm going to do sine of C over C is sine of B over B. Yeah, 17.6 again?
I don't know.
Oh, you want me to do it too? All right, well, we'll find out here. All right, so I'm going to have sine of 43 divided by 12 is sine of B was 49 over B. So I wish I left myself a little more room here.
That's not right. I did.
12 sine 49 degrees is B sine 43 degrees. So B is going to be, I grab my calculator, 12 sine 49 divided by sine 43. I got 13.3. 13.3. Questions on that? All right, so like I say, most of the problems, they're not even going to give you a picture. They're just going to give you the information. So give me some information. What information do you want to give me? Capital A is 47 degrees.
Little a is 7.
Little a is 7.
B is 36.
And big B, 36 degrees. All right. So that's all the information they'll give you. The important thing to notice is you were given a pair, a big A and a little a. To use the law of sines, you always have to have a pair, a big A and a little a. So when will we use the law of cosines? When you don't have a pair. That'll be a law of cosines problem. We'll do that on Wednesday. All right. Well, what can I find without doing a whole lot of work?
Little b.
And what else can I find with even doing less work?
Oh, the big C.
I can find big C pretty easily. Big C is 180 minus 47 minus 36 degrees. So 180 minus 47 minus 36, 97 degrees. And then you said you can find little b fairly easily?
Yep.
Now, I'm going to do something here, and you tell me if this is crazy or not. We usually write sine A over A equals sine B over B. That's the same as A over sine A equals B over sine B. What did I do there? Can I just flip them? Okay, why do I want to flip them is a good
Well, I
question.
mean, how are you allowed?
How am I allowed to do that? Does 3/5 equal 6/10? Yeah, because I can reduce over here, right?
Yeah.
Does 5/3 equal 10/6? Yeah, if I flip both sides, they're still equal, aren't they?
Yeah.
If they're equal and I flip both sides. So, if I'm trying to solve for little b, I like to have little b up on top. So, can you write it this way and then do the cross multiply thing? Sure you can if you want to, but if I'm trying to solve for little b, I like to put little b up on top. Just makes my life slightly easier. So I would write 7 over sine 47 degrees is little b over sine of 36 degrees. And then what do I have to do to get the little b all by itself? How would you get the little b all by itself? Multiply both sides by sine 36. That's exactly right. So I just take my calculator, and I don't have to do the cross multiply thing. It makes my life a little bit easier. 7 times sine 36 divided by sine 47. So little b is 5.6. And then finally, how would I find little c? Do the same thing. I got 5.6. So to find little c, I'm going to do a over sine A is little c over sine c. So I've got 7 over sine 47 is little c over sine 97. And you got what? 9.5. Questions on that? Yes, it does get more difficult. That's an excellent question.
Oh no.
That's an excellent question. If I give you two angles right from the beginning, it's pretty easy. Why is it pretty easy if I give you two angles? The third one is fixed. There's only one possible answer. There's only one thing it could ever possibly be. If I only give you one angle at the beginning, but I give you two sides, that can be more difficult. Because here's what can happen. I'm just going to use the book because they have a nice picture in the book. So if I give you two sides, you end up with what's called the ambiguous case. So imagine if I gave you this angle right here, angle A, and I gave you side A, and I gave you side B. It's possible that side A is too short, and you never get an answer. On the other hand, it's also possible that side A could be just the right length, so you get two answers. One answer where you have an obtuse angle down here, and then one answer where you have all acute angles in your triangle. And then finally, it's possible that side A is exactly the right length to get a right triangle, or side A is exactly the right length so that you only get one answer. So that's where these get harder. If I give you two angles, it's very easy. If I give you two angles, there will be one answer. Always, always, always. No options on that. If I only give you one angle and I give you two sides, you might get no answers, you might get two answers, or you might only get one answer. So that's where these get harder. All right, so let's look at a couple of those. And the good news is, it's not a whole lot harder. All right, so I'm going to give you A is 20, C is 45, and angle A is 125 degrees. Can you use the law of sines? Yes, why can you use the law of sines? You have a pair. You have an A and an A. What can you find first? We know side C, so we can find angle C. So I'm going to have sine of big C divided by little c is sine of big A divided by little a. Sine of C divided by 45 is sine 125 divided by 20. All right, what would you do with that equation? Well, I don't want to flip it because I want to get this C all by itself. Multiply both sides by 45. All right, so sine C is 45 sine 125 degrees over 20. And now I grab my calculator. 45 sine 125 divided by 20. I get sine of C is 1.84. Rounded to two decimal places. So what does that tell you? What's that? It's not a small angle.
Or
It's not 1 degree over here. We have sine of C is 1.84. So we have to do the thing. What's the thing? The sine inverse.
Yeah.
And when I do, sine inverse of 1.84, my calculator says error, domain. How come?
It's not the right.
What kind of numbers can I use when I'm dealing with sine inverse? What kind of numbers can I plug in? Numbers between -1 and +1. Is this between -1 and +1?
No.
So can I do it? So what does that tell me?
It's a no.
There's no such triangle. It's impossible. So this is the ambiguous case because I only gave you one angle. So this is an example of, you get to here, you get to something, this is impossible, that cannot happen, because it's side-side angle, correct? But what this tells you is, this is the example where there's no solution. It's impossible. So that's how you tell when there's no answer. You simply try to solve the way we always try to solve, and you get to that, and that doesn't work, so you say no answer. Yeah.
There's symbols for the solution. Okay, so
Right off from that. All right, so that's a no solution example. How about this one? A is 30. C is 40. And angle A is 37 degrees. Pretty much the same deal, isn't it? We start exactly the same way. We're going to have sine of C divided by little c, that's 40, equals sine of A, sine of 37 degrees, divided by little a, that's 30. That says sine of C is, I grab my calculator, 40 sine 37 divided by 30. 0.802. And I take the inverse sine. Is it going to work this time?
yeah.
So I do the inverse sine. C is, I get 53.4 degrees. But here's the deal. When I hit that sine inverse button, where is sine inverse always going to give me answers? Which quadrants? Not 1 and 2. 1 and 4, because sine is positive in quadrant 1 and it's negative in quadrant 4. So when we use sine inverse, it's always going to give me an answer in quadrant 1 or 4. So it's always going to give me, in this case, since everything's always positive, it's always going to give me an answer in quadrant 1. However, is it possible that I have an obtuse triangle? It is possible. So C might be 43.4 degrees. That's the answer in quadrant 1. Or it's possible that C might be an obtuse angle. So how do I get the angle in quadrant 2 that has the same sign as this angle in quadrant 1? I subtract from 180. So I do 180 minus 53.4 degrees. 180 minus 53.4 is 126.6. So it looks like this one might have two possible answers. It's going to have an acute angle, 53.4 degrees, or it might have an obtuse angle, 126.6 degrees. The directions says, use the law of sines to solve for all possible triangles. So the answer for the first one would be there was no answer. The answer for this one, we will need both. But we're not quite yet sure if there actually are both. And here's what I mean. Right now we have A is 37 degrees. That was given to us. C, we're saying, could be 53.4 degrees. Or C could be 126.6 degrees. We need to check to make sure B works for both of these. Now B will always work for the acute one. That's always going to happen. But it's possible that A and C will add up to be more than 180 degrees. And so angle B would not exist in this case, and then we'd only have one answer. For this one, I think we're going to have two. Because angle B would be, I take 180 minus 37 minus 53.4. Angle B could be 89.6 degrees, or angle B could be 180 minus 37 minus 126.6, which is 16.4 degrees. Sometimes For one of these, you'll get a negative answer. Can you have a negative answer? No, so you would throw it away, and then you would have exactly one answer. But this is an example where we actually have two possible correct answers. So C could be 53.4, in which case B is 89.6, or C could be 126.6, in which case B is 16.4. All right, so what do we have now? We have big A, little a. Big C, little c. Big B, what am I missing? Little b. But since I have two big B's, how many little b's am I going to have? Two little b's also. So I'm going to have to do this twice. Little b, little b. Two possible answers. Okay, so I'm going to have little b divided by sine of big B, sine of 89.6, equals little a, which is 30, divided by sine of big A, which is 37. So one answer is little b has to be that, so that's 30 sine 89.6 divided by sine 37. So little b could be 49.8. And then I have to do it again. I'm going to have little b over sine of 16.4 is 30 over sine 37. And I have to grab my calculator again and type it all in. So that's going to be, the only thing that's going to change is that I get 14.1. So that's as hard as they can get. That's the hardest possible thing that can happen is when you end up with two answers.
There's still only one little c.
There's still only one little c, that's correct. Because little c was given. Little c was given to be 40. We can't change that. So our answers would be, there was the stuff that was given to us. And then here's the stuff we figured out. So there was a lot to figure out in that one. Questions?